Okay, so any questions before we get started? I assume the student who actually come to this lecture is actually the one that finished your midterm one already. I hope everybody is actually doing well enough. Yeah, so what we are going to do today is actually we're going to go slow because as you can see, majority of the students actually are here. Okay, and I'll just give a quick overview about what we're going to head into for the next 4 weeks. Okay, and midterm 2 is actually the one that most of students do poorly. Okay, so the average grade of midterm 2 typically is actually 5 to 10 points lower than the midterm 1. Okay, but after that many years of efforts, I feel like I have a good way to guide you through the calculation. Yeah, so please follow the lead. Okay, watch the video. It's going to be helpful. Okay, so here actually break down the things we're going to have for the midterm 2. Still 3 chapters. Okay, chapter 13, 14, and 15. From chapter 13, which is actually a chapter we're going to go through today, we're going to tell you mainly the definition of acid, base, and salt. Okay, if I give you a solution contains specific acid, base, and salt, can you actually calculate pH? Okay, so pH calculation is so important throughout the midterm 2. Okay, so that's actually something that we will need to actually become a master. Okay, if we see a questions, we should actually immediately know how we can calculate pH. Okay, so we're going to spend roughly 1.5 weeks talking about chapter 13. Okay, so you know when you see a compound, you know it's actually acid, base, or salt. Okay, so that's actually the number one thing we'll go through. And then we're going to head into chapter 14, which will start to talk about the things called buffer. Okay, and then we start to talk about titration, the acid-base titration, okay, which you are going to do the experiment on that in your Gen Chem lab. Okay, and we talk about that for another week, and then we head into the very last one called the insoluble salt. Okay, and the chapter 15 is actually the easiest chapter among the 3. Chapter 14 is actually the most confusing part for the students. Okay, but like I said, I've been teaching this one for many years, right? You should already see the power of my teaching for the midterm 1. if you really actually understand how I do things to solve the questions, you should feel relatively easy for the midterm one. Okay. Do the same thing, you have the same feeling for midterm two. Okay, just follow the lead. Okay. And in the chapter 13, these are the main topic. Okay. So we're going to do a lot of practice. Okay, if I see two chemicals, how can I tell, okay, which one is a stronger acid or base? Okay, so that's actually kind of things that you want to become very familiar with. Okay, when we talk about the acid and base, okay, you should know that there are strong acid, strong base, weak acid, weak base, okay, and buffer. So those are the 5 different kind of solutions you're going to have for CHEM1312. Okay, so can you actually read the text and know what you have is critically important. Okay, so once you understand that, the other very important thing for this chapter is actually we're going to get very familiar with things called the conjugated acid and base pairs. Okay, and after that will be the pH calculation and the percent dissociation. Okay, so those pretty much are the things that we will go through for the next 3 lectures. Before I actually dive in, any other questions? If not, then starting from now, I would strongly encourage everybody, okay, bring one periodic table with you for all the remaining sections for chapter 13 to 15. Okay, because you're going to use like a lot, and that will actually help you to make a lot of predictions. Okay, so first thing first, what is acid? Okay, I think that's actually one of the biggest and most important questions you should ask yourself, right? So what is acid? So the definition of acid actually evolved over time, right? So in the very early young, scientists consider the species that can produce H plus as acid. Okay, so everybody understand the difference between H and H plus. So what's the differences? Yeah, so charge matters. Okay, so the reason charge matters is because once you are charged, okay, you collect electric field around you, okay, and it's going to change your polarity. Okay, so all the environment, if the molecule is actually polarizable, then it will be attracted by you or expelled by you. Okay, H by itself is just a single atom. Okay, it doesn't carry charges, so it's very different species. Okay, when we talk about the acid, okay, acid, okay, from the old time definition is actually the species, once they dissolve in waters, they produce H plus. Okay, how about base? The species they produce what? OH minus. Okay, not OH, but OH minus. Okay, so starting from now, you should really pay attention to charge. Okay, every time I write a chemical formula, pay attention whether I put a charge on it. If you don't see a positive sign or negative sign on the top right corner, meaning it is neutral. Okay, it doesn't carry charges. Okay, so charge is actually a big thing that you need to actually recognize. Okay, you cannot just ignore it. When we talk about the photon concentration inside aqueous solutions, okay, we are talking about the H plus concentration. Okay, so let it be critically clear. Okay, it's not H concentration. Okay, it is H plus concentration. Okay, so those very old theory, okay, we have actually a specific name for like kind of acid-base system, right? It's actually a Brownian acid-base system. Okay, but later on we realized like in the organic solvent you don't have water. Okay, and it's very few species can generate OH minus, but it actually can serve as a base. Okay, so let's later on we have this Lewis acid base definition. Okay, the species that donate electrons is Lewis base, accept electron is Lewis acid. Okay, so let electron transfer become a dominant definition of acid base later on. Okay, but for CHEM1312, for chapters 13 to 15, we only talk about aqueous solution. Therefore, the definition of acid and base, okay, that's meaningful to your homework, to your midterm, will be the H plus and OH minus. Okay, so you need to actually have a clear understanding of that. Okay, it's not that that's actually the ultimate definition of acid base. It's just one of the old time acid base definition. Okay, but things actually all the things we talk about in Gen Chem 2 is in aqueous solution. Therefore, we actually talk a lot more about the calculation on the domain. Okay, but once you actually become more senior, okay, then when you actually don't have the aqueous solution, you start to have organic solvents. Okay, under the case, then the Lewis acid base become the dominant terminology we use if you are chemistry major. Okay, so let's the main differences. Okay, so along the line, okay, one very important concept is called the conjugated acid base. Okay, so what does it mean is that if today I have acid, if I represent that acid using H and A, okay, so H is actually the proton, A is actually the things. Once this species dissociate, you produce H plus and the A minus. Okay, so I use HA to represent acid. Okay, so acid is actually a species that can actually dissociate and produce H plus. Okay, that's actually why I wrote H plus on the right-hand side of the arrows. Okay, and then I write all the remaining one as A minus. Okay, again, I want to emphasize the charge. The things that you have on the left-hand side of the arrow is HA, right? There's actually no plus or minus sign on the top right corner of that molecule, meaning it is neutral. Okay, so on the right hand side, you have H plus and A minus, right? So you have one plus, one minus. So collectively, you also have a neutral condition. Okay, so your charge must be balanced every time you write that arrows, okay, for an equation. Okay, the atoms also need to balance, right? You have one H, one A on the left-hand side, one H, one A on the right-hand side as well. Okay, so you need to be fair, okay, to write a proper chemical reaction. Okay, so pay attention to the atoms, but also the charges. Okay, so here we call this species as a acid. Okay, so once this acid dissociates inside water, it produces H plus. Okay, so that's actually our proton. Okay. The things I want you to focus on is this A minus. Okay, so let A minus, we actually have a very specific term for it. We call it as a conjugated base, okay, of the acid. Therefore, these two, HA and A minus, they are conjugated acid base pair. Okay, so if you just look at these two, you will realize the differences between your conjugated acid and base is just a H plus. Okay, the things that you should be very, very good at is that if I say, give me the conjugated base of HA, if I ask you to give me the conjugated base of HA, then you should know that what you need to do is actually use HA minus 1H plus. Therefore, you know the conjugated base of your HA should be A minus. Okay? So pay attention to the atoms, but also the charge, okay? Everybody got the things I just said? Okay. Okay, so this is what? Acetic acid, okay? If I say, give me the conjugated base of lead guy, can you write? This will be actually a very standard question you're going to have in your homework, okay? What will be the answer? You need to actually subtract lead species by H plus, right? Therefore, you know you should write this. Okay, but you know you need to store away a H, also store away a positive charge, right? Therefore, to put the negative sign on top of it. Okay. Because you store away this guy, therefore this guy will be the conjugated base of this acetic acid. Is that clear? Okay. One more example. What will be the conjugated base of HCl? What will be the answer? Good, Cl minus. One more. What will be the conjugated base of H2SO4? So you see, we start to have different answers, right? So every time when we say the conjugated base, it's actually a species, you only throw away one H plus. Therefore, it will be HSO4 minus. Okay. How about the conjugated base of HSO4 minus? It will be SO4 2 minus. Okay, so every time when we talk about the conjugated acid base, right, it's always throw away one H plus to get your conjugated base, not two. Okay, but if we are polyprotic acid, okay, for example, H2SO4, right, you can do these things twice. Therefore, HSO4 2 minus is the conjugated base of HSO4 minus. And HSO4 minus is actually a conjugated base of H2SO4. Okay, is that clear? Okay, so make sure you understand this terminology. It's very important, okay? So let's say how you figure out the conjugated base, okay? How about a conjugated acid? Okay, so it's kind of like flip the coin. Okay, it's done to actually starting from a base, then you figure out what is actually the conjugated acid. Okay, so typically what you're going to be given is something like this. Okay, what is the conjugated acid of this species? Then the things you need to do is actually you add in H plus. Okay, so if you want to find out the conjugated base, you subtract H plus. If you want to actually find out the conjugated acid, you add in H plus. Okay, so then you go back to H2SO4, right? So this one will be conjugated acid of this species. Okay, so those are the things that you need to be very familiar with. Okay. So let's count the first big important concept that you will need to know. Okay. The next thing that we need to for this chapter is that if I give you a chemical formula, predict is strong acid, strong base, weak acid, weak base. Okay, so it's those kind of questions. Okay. First thing first, the basic idea is that most of the acid and base are weak. Okay, so if you see a chemical formula, you don't know what it is. Okay, if you want to guess, then guess it is weak acid or weak base. Okay, so let's count the default. Okay, so to improve those, the accuracy of your guess, right? It's better to know then what are the strong acid and strong base. Okay, because there's only a very limited amount of strong acid, strong base. If you know that, then you know, or if it doesn't belong to that group, then weak acid, weak base will be the go-to answers, right? So this actually time that you need to, okay, I will go through this first. Talk about the strong acid and strong base first. There are only 7 strong acid. Okay, not a lot, only 7. Okay, and it rank like this. Start from HI, HBr, HClO4, HCl, HClO3, H2SO4, HNO3. Okay. All the strong acid are the acid related to the 7A element. Okay. So the reason I actually bring up the periodic table is that you should start to draw some patterns on your periodic table. Because once you draw the patterns, okay, when you go to CASA, you got a periodic table, right? You can draw on that too. Then you actually help you to memorize all the things. Okay, so make sure you print out next time, print one, okay, and print out and start to draw things on that. Okay, they will actually help you to memorize things as well. Okay, so you can see that if you go to the bottom, it's stronger. Okay, so the strongest one is HI, then HBr. And then the next 3 is actually all related to Cl, right? It's HClO4, then HCl, then HClO3. Okay, so then you already memorize 5, right? And after that, the 2 remaining one is H2SO4, which is sulfuric acid that you know, right? HNO3, nitric acid, you also know that. Okay, so those are the big 7. Okay, so these are the big 7 acids, okay, that you should know. Okay, you should also see that if it is an acid, it must come with H, right? Because H eventually become H plus once they dissociate. Okay, so those are the features that you can actually pay attention to, help to recognize whether you have acid or base. Okay, so 7 strong acid, very easy to memorize. How about strong base? Okay, so if it is these 2 columns, okay, which we call it 1A or 2A elements, if you have oxide, hydroxide, or hydride, in combination with those 2, the elements I highlight in the first 1A and 2A elements, they are strong base. Okay, so that's all the things you need to know about strong acid and strong base. Okay, so I think it's very easy to actually draw the colors on your periodic table, right? Then you can immediately know whether I have strong acid or strong base. Okay, and then after you understand what are the strong acid, strong base, right? Then you go back to this periodic table. If you go to the bottom or go to the right, then you have stronger acid. Go to the bottom to the left, you have a stronger base. Okay, so that's why the table is actually really helpful. Okay, because it's very easy to draw the things I draw here. Okay, so strong, highly recommended you actually print one periodic table out and start to draw on it. Okay. So after that, there's another type of acid that's special. We call it oxalic acid. Okay. So for the oxalic acid, you always have some central atoms, and then you will always come with some protons. Okay. Let's say it's called the central atom C. Okay. You have central atom C, and then beyond that you have the H and then O. Okay, you have certain amount of you have X, H, and Y, O. Okay. Everybody understand why I write this subscript X and Y, meaning that within the chemical formula you have how many of that species, right? For example, so this is actually a type of acid. Okay, to form this acid, we call the phosphine as our central atom. Okay, and then in this specific acid, you have 3 H plus and then 4 oxygen. Okay, or let's say H atom. Okay, hydrogen atom and the oxygen atom. Okay, so this subscript actually describes how many of that kind of atom was presented in the chemical in the molecule. Okay, so this is actually a very standard type of acid we call oxalic acid. Okay, so to compare, oh, this is actually another example we just went through, right? HClO4 and then HClO3, right? So HClO4, you have 4 oxygens for the top one and 3 oxygen for the bottom one. Okay. So how do you know which one is actually stronger if you have an oxalic acid? Okay. If your center atom, they are actually the same. For example, these two, you have Cl, both they are actually the center atom of the both acid, right? Then the HClO4 will be stronger. Okay, and the reason it's stronger is because you actually calculate the difference between the number of oxygen and hydrogen. Okay, if the number of oxygen minus the number of hydrogen, if that number is actually bigger, then you have a stronger acid. And the reason is actually very simple, because you have one more oxygen first, you make the phosphine more electronegative. Okay, so once that part is actually more electronegative, then it's actually it's easier for them to actually give up the H plus. Okay, so that's actually one way to tell which one is actually stronger. Okay, but sometimes you're going to see examples like this. This is actually a case where your number of oxygen minus your number of hydrogen, they are the same, right? So in this case, they all equals to 1, right? 4 minus 3 equals to 1 for both cases. Then which one is actually stronger? Okay. So this is actually a time that you need to start to think about the electronegativity. Okay, so this will be actually the main things that you need to be good at. Okay, so you need to predict which center atom is a atom with stronger electronegativity, then that acid will be stronger. All right. So how do you know which atoms in your periodic table it has stronger electronegativity? Okay, so how do you actually memorize this? Can you see the things I drew? Maybe I should change the color. Okay, so I draw a shape. It's kind of like this shape. Okay, those are the atoms has stronger electron activity. Okay, and then if you actually move into the top and the right corner, the fluorine is actually the one with the strongest electron activity. Okay, and then things actually got decreased when you actually start to spread out. Okay, but those are the ones that have stronger electron activity. Okay, so with that in mind, and you go back and check that molecule we just discussed, H3PO4, and then H3ASO4. You should see that the P is actually the one with stronger electron activity. Okay, therefore you know that acid is actually a stronger acid. All right, so those are pretty much all the rules that you will need to know to predict whether you have a stronger acid when you are given two chemical formulas. All right, so recap these things quickly. First thing is actually majority of things should be weak acid or weak base. There are only 7 strong acids: Hi, HBr, HCl4, HCl, HClO3, H2SO4, HNO3. Okay, and then strong base, first 2 columns, right? 1A or 2A elements combined with oxide, hydroxide, or hydride. Okay, and those are the strong base. Okay, then we start to talk about the oxalic acid, right? If the number of oxalic acid always have this form like HX, center atom, OY, right? So if you have more oxygens, okay, than your hydrogens, then that one will have a stronger acidity. Okay, but if you have different central atoms, then you should talk about or discuss the electron activity of the central atom. Wherever stronger, then it's going to be a stronger acid. Okay, so those are the rules that you need to actually memorize to make the predictions. Okay. One thing about the weak base that is constantly actually show up and confuse student is this. Okay, so amine is the most famous base in Gen Chem 2 that student always got messed up. Okay, that's why I actually intend to actually bring these things up so everybody can see how to interpret these things. Okay, so the structure of amine, okay, we write NH3, right? So chemically, this is actually how it looks like. The center atom is actually your nitrogen. It attached 3 hydrogen, and then on top of it, you have a lone pair. Okay, so this is actually a very standard base. Okay, it doesn't contain OH in it. Okay, that's why many students doesn't recognize this is a base. Okay. So sometimes you will see it written in this form. Okay, R, N, H2. Okay, the R is just the alkyl group. Okay, for example, CH3, NH2. Okay, so CH3, NH2. This is actually something you're going to see frequently, okay, when you look at your homework. Okay, you need to actually recognize that guy structure-wise. It look like this. Okay, you should see that the nitrogen is still attached to hydrogen and 1 CH3. Okay, and typically the chemists use R group to represent those alkyl chains. Okay, so but still the structure is still the same. You still have 1 lone pair on it, which is actually the reason that scientists eventually consider it as a base. Okay, so remember in the beginning I say the more broader definition of base is actually the species that can give out electrons. Okay, amine is actually a good example of that because the lone pair it can use to actually give the electron to the protons. Okay, so it becomes a proton acceptor to make itself a base. All right, so that's actually why this thing is actually a base. Okay, and then if you have this, okay, for example, CH3 2 NH, then what it means is actually you substitute the proton with another methyl group. Okay, you can do these things one more time. Then you have CH3 3, and okay, this is still an amine. Okay, everybody follow this? Because the things I'm going to tell you is actually things that get students so messed up. Okay. Remember we talked about the conjugated acid and base. Okay. You need to know what is the conjugated acid form of all these amines. Okay. For example, if we start from the simplest one. What is the conjugated acid of NH3? It should be NH. Conjugated acid, right? If you want to know the conjugated acid, you add in H plus, right? Therefore, if you add in H plus, you have NH4. Okay, be brave. Okay. How about the charge? There you go. That's the answer. NH4 plus will be the conjugated acid of NH3. Okay? Everybody follow the things I just said? Okay. One more try. What's the conjugated acid of CH3 NH2? CH3 NH3 plus. Okay. How about this? You'll be CH3 right? And then CH3 3 N will become CH3 3 NH plus. Okay. Everybody fine with this? Okay, now the question for you is that this apparently is actually a base, right? How about this? Should that be acid or base? Acid. Okay. So why we call it conjugated acid is because it acts like an acid now. Okay. So why these things is actually confusing? Because if I just give you this, or this, okay, and I just asked you which one is acid, which one is base. Top one is acid, bottom one is base, right? It's very straightforward for you now, right? But if I don't explain this to you, I just give you these two formula. Can you confidently say the top one is acid, bottom one is base? Okay, reality is actually no, student cannot. Okay, because they don't have very strong understanding about the conjugated acid and base concept. And they look so similar, right? And there's actually no clear like OH inside the formula. Therefore, students always got confused. When they see this, they don't know it's actually acid or base. Okay, that's why this one actually is the number one thing that CHEM1312 students fail to comprehend. Okay, and I hope that you actually got to understand the differences between the top and bottom one, where the top one is an acid, bottom one is a base. Very, very important. Okay. All right. So once we understand this, the very last important concept that we want to talk about is this. The acid base, the acidity or basicity of the salt. Okay, the salt is actually another thing that we need to know. Once you dissociate, okay, it's going to form a acidic or basic solution. Okay. And this actually comes up with these three very lengthy description. Okay, so the first thing says that the conjugated base of a strong acid is neutral. Okay, so what does this mean? So let's say we have a strong acid. HI is a strong acid, right? What is the conjugated base of HI? I minus, right? I minus. Okay. So the I minus itself is actually neutral. Okay. The things that make the HI a strong acid is because the H plus, okay, is acidic, right? The H plus is actually the source of acidity. Okay. I minus itself is actually neutral. All the acidity coming from the H plus. Okay. Now, strong base, right? Let's say the most famous example, sodium hydroxide, right? A strong base. Once this is dissociate, what do you get? Sodium plus, and then OH minus, right? Okay. This is the conjugated acid of sodium hydroxide. Okay. And sodium plus itself is also neutral. Okay, so let's actually first things that we need to know. If today you have the conjugated acid or base of a stronger species, okay, then it will be neutral. Okay, in this case, the I minus and sodium plus are the neutral species. Okay. These two is saying the same thing. Okay, CH3 COOH. Is it a strong or weak? Weak. Acid or base? Acid. How do you know it's actually acid? So typically, okay, for the functional group, you see COOH. Okay, that's actually the very standard chemical formula of acid. Okay. So this is actually going to be an acid. Okay. How do you know it's actually weak? Not the big seven, therefore it's weak. Okay, that's why it's so important that you remember the big seven. Okay, once you know the big 7, you know, okay, this has to be a weak acid. Okay. Then can you actually write out the conjugated base of this acid? It will be CH3COO minus, right? So this guy is actually the source of your acidity. How about this? Should it be acidic or basic? Basic. Okay, it's a conjugated base of a strong acid. Therefore, it will be a base. Strong or weak? Weak. Okay. So those are the questions. Now, those are the concepts that you should know. So this will be a weak base. This will be the weak acid. Okay. Similarly, if today you have this one is what? Acid or base? Base. Strong or weak? How about this? Acid, weak. Okay. So you need to actually know what the species that you have. All right. So those are the things that you must have. So actually go through the 3 questions for today's lecture. But before it goes into the questions, any specific anything that you don't understand? So the things we went through today is going to be the concept that you should have for this chapter. Okay, if you can fully understand what I'm talking about today, you have all the necessary concept already. Okay, very simple, right? Okay, so this is actually a very standard type of questions you're going to be asked. Okay, so I give you a bunch of chemical formula. Okay, start to actually group the things into strong acid, strong base, weak acid, weak base. Okay, so first one, NH3. Very good, weak base. How about this? Hmm? Weak base. How do you know it's weak base? So which part should you actually focus on? Yes. Okay. You want to start to pay attention. How many atoms is actually attached to your N? Right. So you see, I wrote this very long. This is very long, right? All this is just a alkyl group. You can just replace with R. Okay. That means actually your amine attached to a long chain alkyl chain, right? And then attach another 2 hydrogen. Okay. So attach 3 species. Okay. And more importantly, it's actually the charge. Is it charged? No, it is not charged, right? Only the charged amine will become acidic. If you don't see the charge, okay, if you can see that it only attached to 3 species, then it will be a weak base, right? And then you should see, yes.
CH3 only.
Oh, okay. I guess this is actually like lack of knowledge about this R group, right? So every time you see I draw this R group, okay. So what the R group is actually just a bunch of CH things. It doesn't really matter. It's 1 carbon, 2 carbon, 3 carbon, 4 carbon. It doesn't really matter. But as long as that thing contains only your C and H, okay, regardless of CX, HY, okay, it doesn't really matter how many carbon atoms or hydrogen atoms. It doesn't really matter. It just means actually it's a long chain compound or long chain species that contain only your C and H. Okay. In chemistry, we consider then we always call those kind of species as R group. Okay. And you can consider that it's just a things that attach to amine. Okay. And the only thing that's different from H is that it is not a H that can dissociate. Okay. So even though I roll like CH3, CH2, CH2, right? I can make it even much longer. I can put like 10 carbons over there and then associate a different amount of hydrogen. That's fine too. You can replace the whole thing as R. Okay, because the things that really matter is actually the amine. Amine is actually called a functional group. Okay, so you'll hear this term functional group a lot in chemistry because different functional groups have different properties. Okay, but those functional groups will actually dictate the property of the whole molecule. Okay, so in this case, amine, the N is actually the functional group. Okay, so that's actually the key that will determine the property of the molecule. All right, just like the acid COOH, right? It's also a functional group. Okay, if you have a less specific functional group presented inside your chemical formula, then they will dictate the property of the molecule. Okay, is that clear? Cool. All right, so make sure you pay attention to how many atoms attached to your N and whether that species is charged, right? Because once it is actually positively charged, okay, then you will always attach to 4 different groups and you will always become a weak acid. But if it's actually neutral, then you know it has to be a weak base. Okay, so let's say things that you should know. How about this? Weak acid, very good. How do you know it's actually weak acid? This is actually a very standard type of oxalic acid, right? You see the H, some center atom, and O, right? So that's actually a very typical format of oxalic acid. Okay, so starting from this chapter, I want you to start to see, okay, not the specific letters within the chemical formula, okay, but start to recognize, okay, it's actually strong or weak. Is it acid or base? Okay, those are the things that you need to be very good at because those are things that really matters. Okay, so to see through the letters and really understand the nature of the molecule. Okay, how about this guy? Strong base, right? So the functional group of this molecule is that OH, right? And then start to see the remaining part, the RB. Okay, that's the time that you want to actually go back and check your periodic table, right? RB is actually your 1A element. Okay, so if you have 1A or 2A element associated with hydroxide, which is OH, oxide, which is O, or hydra, which is H, okay, then it will be a strong base. Okay, next one. It's actually one of the big 7, right? So strong acid. Okay, so these are the type of questions you're going to encounter. But if you actually memorize the simple rule here for you, this should be actually very straightforward. Okay, I want to talk about number 3 first. Okay, so this is actually the salt problems. Okay, so in an aqueous solution of NaNO3, acidic, basic, or neutral. Okay. The way you solve this is that first step is that to recognize that this is a salt. Okay, so how do you know it is actually a salt? if you look at the chemical formula, okay, the typical things you're going to see is that it contains 1A, 2A, or 7A elements. Okay, so what do I mean by that? Again, go back to your PR tables. One A, 2A, and 7A, which is this, and this. Okay, so you have a sodium, lithium, potassium. That's actually 1A, right? Or you have magnesium, calcium. That's actually your 2A. Okay. Oh, you have 7A, chloride, bromide, iodide. Okay. So if you see a chemical formula contains those species, okay, there's actually high chance you actually have a salt. Okay. The other thing that you should know is that when you throw a salt into an aqueous solution, it's going to dissociate, right? So the atom in your 1A element, it will always be +1 charged. Okay, 2A will be +2. Okay, 7A will be -1. Okay, so that's something that you need to actually memorize. Okay, so anything in your 1A elements, once it dissociates, they give you +1. This give you +2. That give you -1. Okay, so those are the prior knowledge you should actually have. Now get back to this. The first question, NaNO3. Okay, can you recognize that this is actually your 1A element? Right, sodium is actually in your 1A. Unfortunately, we don't have a table I can point to, but sodium is actually 1A. Okay, therefore you know, once it dissociates, you have Na plus and then NO3 minus. Okay, everybody follow this? Okay, so Na plus, okay. Remember we say the conjugated acid of your strong base, it will be neutral. Okay. And then the conjugated base of a strong acid, this one will be neutral as well, right? So let's count the things we talk about. Right here. Okay. So if you are actually the counterpart of a strong acid or strong base, then you will be neutral. Okay. And then if you look at the species that we have, this cations is actually the conjugated acid of NaOH. Okay, a strong base. Therefore, this one will be neutral. This will be the conjugated base of the acid HNO3, right? And HNO3 is a strong acid. Therefore, its conjugated base will be neutral as well. Okay, so the two species that show up inside your solution, both are neutral. Therefore, you know when this salt dissociates, it only produces neutral species. Therefore, your solution will be neutral. Okay, so let's actually how you solve this type of questions. Okay, therefore, solution will be neutral. Okay. Second, NaCH3COO. Once this thing dissociate, again, it produces Na plus. And then the remaining part will be CH3COO minus. Okay. Na, again, is neutral. This guy, this will be a conjugated base of CH3COOH, which is a weak acid, right? Therefore, its conjugated base will be a weak base. Okay. Therefore, you know, in this solution, you have a neutral sodium plus and weak base CH3COO minus. Therefore, the solution will be a weak base solution. Okay. Very last one. C2H5 NH3Br. You will become C2H5 NH3 plus Br minus. Br minus is 7A, right? It's actually the conjugated base of HBr, which is actually a strong acid. Therefore, this guy will be neutral. This is this acidic or basic? Acidic, a weak acid, right? Therefore, you know this guy is just weak acid. Therefore, your solution, since this is neutral, this one will dominate, will be a weak acid solution. Okay, so this is actually how you predict whether the salt solution is actually acidic, basic, or neutral. Okay, any questions for this? Okay. If not, then this one will be the most complicated questions for today's questions. All right. And this will be the very last question we discussed today. Okay, consider the reaction below using your knowledge of relative acid-base strengths and equilibrium. Determine you can say about the size of the Kc. Should the Kc be larger, equal, or smaller than 1? Okay, then you see these equations. You should be able to see in these chemical equations, there are actually two conjugated acid-base pair, right? So this and that is actually a pair. Okay. This and this is another pair, right? So if you look at the highlighted one first, which one is actually acid? H3 SbO3 is the acid, right? So this is actually acid 1. This is the conjugated base 1, right? How about the other pair? HTeO3 minus and then H2TeO3. Which one is actually your acid? So this one is your acid 2, right? And this one will be your conjugated base 2. So this is actually a pair. That is actually a pair. Okay. So let's actually set up you should have first. Okay. Then what it's asking you is actually you have two acids you have one on each side, right? Okay. If your H3SbO3 is stronger than your H2TeO3, then the reaction will be pushed to the reactant side or product side? Okay, so let me write this down so I can think about this. Okay, so let's say if your H3 SbO3 is stronger acid than your H2 TeO3. Okay, since it's actually stronger acid, right? It's going to dissociate more. Okay, therefore, then the reaction will be pushed to the right. Okay, so if reaction pushed to the right, that means your K is going to be larger than 1, right? Because K, you can consider K as the ratio between your product over reactant. Okay, so if that is true, then your K should be larger than 1. Okay, if it's actually smaller, then your K will be -1. If they're the same, then K equals to 1. Make sense? Okay, so now you need to start to consider. Okay, so which one is actually stronger? Okay, so H3 SbO3 and H2 TeO3. Okay. I want to refresh your memory while we talk about this. Okay, you all go back to this. When we talk about the acidic acid, if the center atom are the same, then all you need to do is actually to count the difference between your oxygen and then the hydrogen number, right? So the one that give you a larger number will be the stronger one. Unfortunately, you don't actually have the same center atom. Okay, so under that case, the things that really matter is actually all about your electronegativity. Okay, then you want to start to actually go back to this plot, right? And then the things you want to compare is actually SB and EE, right? So which one is actually stronger? EE, right? So the one that's close to that box, right? To the top right corner will be the stronger one. Apparently your TE is actually more close to the box. Therefore, the electronegativity will be larger. Okay, so okay, so we know T. The electron activity is stronger than Sb, right? Therefore, H2 EeO3 will be a stronger acid than H3 SbO3. Therefore, reaction is going to move to the left. Therefore, your K will be smaller than 1. Okay, so this is actually a very standard type of questions. It tests you actually about a few things. First, can you recognize the conjugated acid base within the system, within the equation? Okay, and you will always be able to identify the acid on both sides. Okay, and then you want to compare the relative acidic strengths of those acids. Therefore, you can actually compare, you can actually predict the K will be larger, equal, or smaller than 1. Okay, so those are the things that you're going to encounter for your homework and quiz. Okay, so we'll stop here today. And if you haven't taken midterm 1, okay, good luck with your midterm 1. If you already finished your midterm 1, you will be able to visit your exam on Thursday, right? First thing you do is actually download your midterm 1 exam with answers, okay? Because you will need that for the final exam.